Number 1, find all the linear factors given one factor. So if x plus 5 is a factor, then the 0 is negative 5. So if x plus 5 is a factor, you said x plus 5 equal to 0, so negative 5 is a 0. I'm going to use negative 5 in the house. And I'm going to use 1, 9, 23, and 15 in my synthetic division. So those are the coefficients of that polynomial. Bring down the 1. 1 times negative 5, negative 5. Positive 4. 4 times negative 5, negative 20. Positive 3. 3 times negative 5, negative 15, 0. You should get 0 because we know negative 5 is a 0. What's left is the polynomial x squared plus 4x plus 3. It says find all of the linear factors. So that means we need to factor this polynomial. Well, that's easy because we know two numbers that multiply to 3 and add to 4 are x plus 1 and x plus 3. So it says find all the linear factors. What does that mean? That means x plus 1, x plus 3, and of course the original one they gave us, x plus 5. Number 2, x minus 3 is the 0, which means 3 is the, or x minus 3 is the factor, which means 3 is the 0. Put 3 in the house, 3, 4, negative 35, negative 12. Synthetic division, bring down the 3, 9, add 13, multiply 39, add 4, multiply 12, add 0. Again, you should get 0 for your remainder. Now we're taking our quadratic, 3x squared plus 13x plus 4, and we are factoring it. You can use split the middle. You can use guess and check. Remember, trial and error. So if I put a plus 4 and a plus 1, I get 3x squared plus 12x plus 1x. There's your 13x plus 4. So that means my 3 linear factors are 3x plus 1, x plus 4, x minus 3. Number 3. Now our polynomial has a degree of 4. This means that we will do synthetic division twice, all right? It's your choice for what you want to put in the house first. If x plus 1 is the factor, then the 0 is negative 1. So 3, negative 10, negative 24, negative 6, and 5. So 4, 3, 2, 1. Okay, we've got all of the coefficients there. Bring down the 3, negative 3, negative 13, 13, 11, negative, 11, 5, negative 5, 0. And again, I say to you, if you don't get a remainder of 0, something went wrong. Now, we knew that x plus 1 is a factor, and so we use negative 1 in the house. If x minus 5 is a factor, then 5 goes into the house. And we can use those same numbers, okay? So 3, negative 13, negative 11, and 5. Synthetic division again. Bring down the 3, 15, add 2, 10, negative 1, negative 5, 0. So when we did the first synthetic division, the numbers at the bottom represented a cubic polynomial. It's always one less than the original. So then when we use the cubic and we do synthetic division, this is a quadratic. So 3x squared plus 2x minus 1. Go ahead and factor it. And again, you can use split the middle. You can use guess and check. So 3x, x. We got to get a 2 in the middle. That's positive. So how about plus, let's think about that. Multiplies to negative 1. So plus 1 minus 1. Let's see if that works. So it multiplies to negative 1. So 3x squared plus 3x. I'm just doing FOIL out loud. 3x squared plus 3x minus 1x is a positive 2x minus 1. So my factors are 3x minus 1, x plus 1, x plus 1, and x minus 5. So when you are asked to write the polynomial as a product of factors, You could rewrite this as f of x equals x plus 1, x minus 5, 3x minus 1, x plus 1. Number 4, we're going to do the same thing. So I'm going to put negative 4 in the house. That's going to be 1, negative 4, negative 20, 48, and 0. The constant term is not there, so you must hold a place for it. 1, negative 4, negative 8, 32, 12, negative 48, 0, 0, 0. So in the end, you still have a remainder of 0. Now, be careful, because this was originally a quartic polynomial, and so this line here, I'll put a yellow dot there, is cubic. Keep that in mind. The next 0 that you're going to put in the house is 2. That's going to be 1, negative 8, so x cubed, x squared, x, and then again 0. Bring down the 1. 1 times 2 is 2, negative 6, negative 12, 0. This was x to the 4th, so this is x to the 3rd, and so this is x squared. Really important that so x squared minus 6. How do we factor that, right? Because that's not the difference of perfect squares. So when you factor x squared minus 6, as I said, it's not perfect squares. So that factors into x minus the square root of 6 and x plus the square root of 6. So those are your factors. Okay, moving on to number 5. Find all the zeros given one or more zeros. All right, so we're given a 0 of negative 3. Now you notice I haven't gone to Desmos at all. So I'm going to strictly show you how to do this worksheet in all algebraic method. Make sure you know algebraically how to support anything that you get from Desmos. Negative 3 in the house, 4, 12, negative 1, negative 3. 4, negative 12, 0, 0, negative 1, 3, 0. That was x cubed, so this is 4x squared minus 1. Find all the zeros, so now we are finding the 0, so we are actually solving now. So 4x squared minus 1 equals 0. 4x squared equals 1. X squared equals 1/4. Take the square root of both sides. X is plus or minus a half. So there's our 3 zeros. Number 6, negative 1 in the house, 3, 2, negative 1, 0. Synthetic division. Bring down the 3, negative 1, 1, 0. That was an x cubed, so this is an x squared. 3x squared minus 1 equals 0. So now we're going to solve. X squared minus 1 equals 0. 3x squared equals 1. X squared equals 1/3. X equals plus or minus the square root of 1/3. Now, technically, you can't leave your solutions like that because you shouldn't have a fraction inside of a radical. So what do you do with an answer like that? Well, the proper thing to do is to separate. So plus or minus the square root of 1 over the square root of 3. And then you might have learned at some point this process called rationalizing. And so you end up with plus or minus the square root of 3 over 3. And so those are your other two solutions to your cubic. All right, the next section says find all roots by factoring. Oh my gosh, factoring. I love factoring. So f of x equals, let's group and group. And let's cross our fingers when grouping that it works. GCF, x cubed, x minus 2. GCF, negative 3x, x minus 2. Well, here we go. We see our common factor of x minus 2. And so that's going to be the GCF with x cubed minus 3x. What do we do now? we set each one of them equal to 0. So x minus 2 equals 0, and x cubed minus 3x equals 0. This first one is easy, x equals 2. The second one involves more factoring. We can additionally pull out a GCF of x with x squared minus 3. Therefore, we have x equals 0 and x squared, oops, that should be a 3, minus 3 equals 0. Finishing it off, x squared equals 3, x equals plus or minus root 3. Now, I say to you, if you had put that polynomial into Desmos, you could have found all 4 roots. They're all real. But when you clicked on the roots that were plus or minus root 3, they're going to show up as decimals. And so what's new now as we work towards the end of this topic is that when I say to you, find all roots, and you can have decimals, then this is the technique that you need to use so that you end up with the exact zeros and not decimal approximations. Number 8, let's factor again. Group, group. So that's going to be f of x equals GCF x squared, x plus 5. And the second GCF is just 1, x plus 5. There you see your x plus 5 is your GCF. And so f of x equals x plus 5, x squared plus 1. Set each one equal to 0. X plus 5 equals 0. X squared plus 1 equals 0. X equals negative 5. X squared equals negative 1. X equals plus or minus. Please don't forget the plus or minus. The square root of negative 1, which is plus or minus I. Now, you know that the cubic polynomial has 3 zeros. One of them is real, so I'm reminding you, this is the real one, and this represents the 2 imaginary zeros. So there are 3 zeros, in fact, right? But 2 of them are non-real, and the non-real always come in pairs. Number 9, factoring again. So 2x cubed. Nope, wrong. Not a GCF. X cubed is the GCF with 2x minus 1. Minus 9x with 2x minus 1. When you factor by grouping, remember that the goal is to end up with the same binomial. And so as you are pulling out your GCF, keep that in mind, right? Now just don't force it to be the same, but it will be the same if you factor the GCF out correctly. So there's your x cubed, leaving you with 2x minus 1. And then when you look at that second set, you will pull out the negative, which you should always do, 9x, and that leaves you with 2x minus 1. So now we've got 2x minus 1, x cubed minus 9x. Again, setting them equal to 0, 2x minus 1 equals 0, 2x equals 1, x equals a half. But let's look at the next one. The next one is going to involve more factoring. Pull out your x squared minus 9. Oh, now we have difference of squares. X minus 3, x plus 3. And so your 3 zeros are 0, 3, and negative 3. And there is your sum total of 4 zeros. Okay, x to the 4th minus 6x squared plus 8. This is a quartic polynomial, but there's only 3 terms. There's a trick here. You can factor this the same way you factor a quadratic. What is different is that in the binomials, you will write x squared instead of x. You will follow the same pattern. We're looking for 2 numbers that multiply to be 8 and add to be negative 6. So minus 4 and minus 2. Because when you add them, you get a negative 6, and when you multiply them, you get a positive 8. But what does that look like when we're solving? Well, x squared minus 4 equals 0, and x squared minus 2 equals 0. You can solve by factoring. You can solve by square rooting. So x squared minus 4 equals 0, x squared equals 4, x equals plus or minus root 4, x equals plus or minus 2. X squared equals 2, x equals plus or minus root 2. So there you go. 2 zeros, 2 more zeros gives you your sum total of 4 zeros because the degree of number 10 is 4. It's a quartic. All right, last two. X cubed minus x squared plus x minus 1. Factor by grouping. The first set has a GCF of x squared with an x minus 1. The second one, the only GCF is the number 1. There's your common binomial. So x minus 1 times x squared plus 1. Set it equal to 0. X equals 1. X squared plus 1 equals 0. X squared equals negative 1. X equals plus or minus root negative 1, which is plus or minus I. Now, before I move on, I want to remind you that when you graph number 11, you will only see one real 0 at 1. You know there are 3 zeros because it's a cubic polynomial. The other 2 are non-real. So x equals plus or minus I, x equals 1. Okay, the last one is our good old cubic polynomial. And we need to factor it. So let's remind you of that. How do we factor the cubic, right? Remember, a cubed plus b cubed factors into a minus b, a squared plus ab plus b squared. Oh, actually, if it's plus, that's going to be a plus here and fix, a minus there. All right? Have that written down somewhere in your preparation for the test. All right, so that's going to be x minus 2, x squared. No, not x minus, it's x plus, because this is a plus. X squared minus 2x plus 4. The first step is factoring. The second step is solving. The first one solves easily. X plus 2 equals 0. X equals negative 2. In fact, if you were to graph that polynomial in Desmos, you would see a 0 at negative 2. But you know that since it's cubic, there are 2 more zeros. So x squared minus 2x plus 4 has to be solved using the quad formula. X equals the opposite of b, that's a positive 2. Plus or minus the square root of b squared, 4 minus 4 times 1 times 4, all over 2 times 1. That's 2 plus or minus the square root of 4 minus 16 is a negative 12. We now need to simplify, and the answer is 2i root 3. How did I get that? Let me go over here and show you. The square root of negative 12 is the square root of negative 4 times the square root of positive 3. The square root of negative 4 simplifies to 2i, so 2i root 3. Let's break it apart. 2 over 2 plus or minus 2i root 3 over 2. And so that's 1 plus or minus I root 3. And there are my 3 zeros. Here's 2 of them. They are complex. They come in pairs. 1 plus I root 3, 1 minus I root 3. And then your third 0 is x equals negative 2.